Today we're going to talk about section 8.7, which is inverse matrices. You remember when you multiply two things together, like if you have 5 times 1/5, that equals 1, and these are called inverses of each other, and this is the multiplicative identity, 1. Well, for matrices, you have the same thing. So the first thing you need to realize is that this works with square matrices, and the identity matrix is when you have ones down the diagonal all the way down and zeros everywhere else. So an inverse is where it multiplies and you get the identity. The way we write that is that we have a matrix A, we multiply it times its inverse. That's how we notate the inverse. And that equals the identity. And if it's inverse, it works on the left or on the right. Because remember, multiplication of matrices is not commutative, but with square matrices, their inverse, either way, should get the identity matrix. So how do we find these? An identity matrix, or an inverse matrix for a 2x2 is pretty simple. If we have a 2x2 matrix, then the inverse is 1 over its determinant, and then you switch things on the main diagonal and change the signs on the other diagonal. So for a 2x2 matrix, then this is all you have to do. Now, if the inverse, or if the determinant equals 0, then the inverse does not exist. Okay? Not all matrices have inverses. Even some square ones don't have inverses, so you have to pay attention to that. If the determinant's 0, you don't have an inverse. So let's do an example. If we have A is this matrix here, 4, 7, -3, 10. Then the inverse, well, we need 1 over the determinant. So the determinant, remember for a 2x2, you just multiply the diagonals. So we have 40 minus -21, which is 61. So we have 1 over 61 times, switch the main diagonal, change the signs on the other diagonal, and we have our inverse. So multiply that scalar in there. And there's our inverse. So when you multiply this one times this one, you should get an identity matrix. Now, the other way to find this is with augmented matrices. What you do is if you have a matrix, let's say we have this matrix A, and we want to find its identity or its inverse by using an augmented with the identity. So what you do is you've got 8, 2, 6, 7, and then we do our augmented matrix with an identity matrix here. And then we're going to use like the Gaussian elimination type row operations so that we end up with our identity on this side. And when we've switched these two, what's left over here will be the inverse. So we start out with A and the identity, and we're going to end up with the identity and the inverse. So how do we do that? Well, let's start with, we need a 1 here, so let's just multiply that row through by 1/8. So 1/8 times row 1, and we get 1, 1/4, 1/8, and 0. And then we need 0 here, so we're going to take 3 times row 1 minus 4 times row 2. So that's 24 minus 24 is 0. And then 6 minus 28 is -22. And then 3 minus 0 is 3. And 0 minus 4 is -4. So we've got our 0 here, and we've got our 1 here. Now we need this to be a 1, so we can multiply through by negative 1 over 22. So we leave this one the way it is for now. Multiply this one times negative 1 over 22, and we end up with 1, negative 3 over 22, and 2 over 11. Now, we've almost got it. We've got our 1's on the diagonal, we've got a 0 here, but we need a 0 here as well. So the way to get that, we've got multiply the top one, negative 1/4 times this second row plus the first row. So negative 1/4 times 0 plus 1 is 1. And then negative 1/4 times 1 plus 1/4 is 0. Negative 1/4 times negative 3/22 plus 1/8 is, you got to do all those fractions there, 7/44. And then negative 1/4 times 2/11 plus 0 is negative 1/22. And then the next row we just leave because it was like we wanted it. And so here we've got our identity, and this is our inverse. So that's two different ways to find the inverse. You can use the formula 1 over the determinant times and then switch the main diagonal and change the signs on the other diagonal, or you can do an augmented matrix with the identity on this side and do your row operations till you end up with the identity on the left instead. Now, the thing about this one is this works for all sizes. So you can augment it with your identity no matter what size it is. No matter, it has to be square, but it can be 2 by 2, 3 by 3, 4 by 4, whatever. And then you can do your row operation so you end up with your identity on the left, and then you'll have your inverse on the other side. Now, we've talked about lots of different ways to solve equations, and these inverses is one way to help us solve equations. So if we have this, let's set up a system of equations here and use our inverses to solve them. Okay, so we've got 4 variables, which means in order to get a particular solution, we've got to have 4 equations. So if we have less than 4 equations, we're going to have our general solution. But I'm going to go ahead and give you 4 so that we can now, when we solve equations with just numbers, we use inverse operations to undo them. For example, if we have 5x equals 25, if we want to know what x is, well, 5 is multiplied times x, so the inverse operation is a division, so we divide on both sides and we get that x is equal to 5. Well, with systems of equations, we have matrices that are multiplied together. Remember, this is just, put our coefficient matrix up. We've got 7, 3, negative 3, 2, negative 5, 0, 2, negative 3, 1, 8, negative 6, 4, negative 9, negative 1, negative 2, negative 5. And then that's times our variable matrix. And that equals our answers. So we have an equation here that's with matrix multiplication. Well, we don't have a division for matrix multiplication, but it does actually work out with inverses. So let's say we call this AX equals C. So this is matrix A, and this is X, and this is C. If we multiply on the left, make sure you're paying attention to which side you're doing, by the inverse on each side, then this together, A inverse times A, is the identity matrix. Well, an identity matrix times anything, it's just like multiplying times 1. So it keeps its identity. So our identity matrix times X is just X. So if we want to be able to solve this, we can multiply our inverse matrix times the answers, and we end up getting our solution fairly easily. Now, we've talked about several times about how to do these things. You can find this inverse by augmenting and with the identity and do your row operations and everything. But we've all talked about how with 2x2s, I want you to know how to do it. And with 3x3s, I need you to be fairly comfortable. But when it comes to the bigger matrices, we're not really going to worry about being able to do that with by hand. So what I need you to do is we're going to see if we can get the calculator to cooperate here. And if you remember, you can go to matrix and just pick one of them, whichever one you want to edit. And we're going to have a 4x4 matrix for our coefficients. So you would need to enter all your coefficients into one of the matrices. It's 4x4. Remember, we talked about how to do this in class. And then you also need to edit one of your matrices to be the answer column. Now, I've called mine C and D just for ease so that I could leave them in there. It doesn't really matter. Now, once you have them entered in there, and go ahead and pause it if you need to get everything all entered in, you need to go back to the home screen once you've got that done. Now, you can do an inverse matrix by pulling up the name that you want. And then there's an inverse button. It's the same one that says matrix in blue, the x to the negative first power. That's the inverse button. And it's going to give you the inverse matrix. And it's depending on whether you have yours set up to do fractions or decimals, it'll give it to you in big long decimals because most of the time these inverses are not pretty. So if we want to solve this, well, we said over here that by multiplying our, let's see, mine's called C, the coefficient matrix C. If I multiply the inverse of that times that answer matrix, which I call D in my calculator, then I'm going to get my X values. So if I take and I pull up matrix C, and then I want its inverse, and then times matrix D, then I'm going to get a new matrix here. And what this tells me is that x1 equals 2, x2 equals 3, x3 equals 5, and x4 equals 6. So you can use your calculator and these inverses to solve these systems. Now, what do I expect as far as calculators versus hand? Again, 2x2s, and sometimes with 3x3s, I expect you to be able to do those by hands. These bigger ones, obviously we're just going to use the calculator because it's kind of pointless to waste our technology here. So once you understand what an inverse is, remember an inverse times it's a matrix is that identity matrix, that 1 down the main diagonals and 0 everywhere else. And once you understand how to get the inverse, then you can use your calculator for these bigger ones and figure these things out. Make sure you've read the section thoroughly and that you understand what an inverse is and what the identity is and how to use those, and we'll go over it some more in class.